Right. Let's start by taking some questions from last time or the last homework assignment. Okay. Oh, yeah, I need to do that, don't I? Yes, thank you. I'll make sure I do that. Kirch? 7. Okay. So for 5 through 10, we're asked, are there 0, 1, or 2 triangles possible? For these given measurements. So the first thing I'm going to do is check to see if I'm even in the ambiguous case situation. So I see I have an acute angle, and the side opposite that acute angle is shorter than the other given side. So this is the ambiguous case. Okay. So to determine whether I have 0, 1, or 2 triangles, I'm going to use the law of sines. Everybody okay here? What I'm going to do then is I'm going to get sine q by itself by cross multiplying and then dividing. Okay? And now I'm going to evaluate whatever this is on my calculator. So I want the numeric value for that. So I'm going to do 15 times sine of 65 divided by 13. And I get 1.05. And since that's greater than 1, 0 triangles are possible. If it's equal to exactly 1, 1 triangle is possible. If it's equal to less than 1, 2 triangles are possible. So that's what you do to check in an ambiguous case, whether you have 0, 1, or 2 triangles. Okay with that? Michael? Oh, I'm sorry. Jackie. I was talking to Michael. Sure. So there's 2 things you need to have. The given angle needs to be acute, so less than 90, and the side opposite that acute angle has to be the smaller of the 2 sides. And that's the situation where you can have 0, 1, or 2. If this side was the bigger of the 2, 1 triangle only. Don't have to think about it. Bella, you had a hand?
Oh, definitely.
Okay. Ben.
So if they give you like E equals 65 degrees, Q equals 15, and D equals 13, it's the corresponding side of the angle, right?
So what? Can you repeat what you said?
Like all the ones they give to us, you take the first side length and use that.
Well, the letter should match.
Okay, yeah.
The letter would match. Yeah. So the side that needs to be shorter would be the same letter as the angle. Yeah. Okay. Other questions from this? Happy to do some more if you guys want to talk about some more of these. Jack? Absolutely. Does anybody have a preference on 11 through 14?
No. 14.
14. Okay. So, first thing, let's observe that this is indeed the ambiguous case. So I have an acute angle, and then the side opposite the acute angle is the shorter of the 2 sides. Everybody agree? So this is the ambiguous case. So let's determine how many triangles we should be looking for. obviously, like I realize from the context of the question, we know there's two triangles, but I'm pretending that because it doesn't really hurt to do this. All right, so I'm going to cross multiply and divide to get the sine A by itself. And I get something that's less than 1. So that tells me there's two triangles. So to get the value for sine or for angle A in one of the two triangles, I'm just going to do sine inverse of that stuff. So 67.300. I'll just call it 67.3. I'm going to round these to 3 decimal places, I think is what I did in the answer key. Oh, no, just 2 decimal places apparently. That's fine, whatever. Okay. So before we go and deal with anything in triangle 2, let's just kind of label this out a little bit so that everybody's clear as to what I'm doing here. So triangle 1, I know the value for angle A we just found is this. Angle B was given to us. Angle C we haven't found yet. Side A we know that was given to us. Side B we know that was given to us. Side C we haven't found yet. For triangle 2, we don't know anything other than the givens right now. Jackie, you good with how I've kind of set this up? Just to kind of keep things organized. And actually, let's I guess we'll take that and put it down here. That's not at all where I wanted that to go. Cool. All right, so I'll put that work on that side, so it's a triangle 1 work. Does that feel okay, just in terms of me organizing things? If you go back and look at this, it'll hopefully make a little bit more sense. So in triangle 2, how do I find angle A? I just do 180 minus the angle A from triangle 1. It's always going to be supplementary to it. So that'll always be how I find that other angle. So 112.7. Everybody okay there? Now angle C is going to be easy now, right? In each case, to find angle C, I'm just going to do 180 minus angle A and minus angle B. Now, keep in mind, angle A is a different measure in each of the two triangles, but I'm still going to find angle C the same way. Cool with that. All right. Let's pop those out real quick. So 55.7 over here. And then over on the other side, 180 minus, and minus 57. So 10.3. Good there. Okay. Now that we have angle C, we can find, or I'm sorry, side C, we can, yes. Now that we have angle C, we can find side C. So I'm going to use the law of sines to do that. So I'm going to do sine of angle B over side B is equal to the sine of angle C, which in this case was 55.7 over side C. So I can cross multiply and divide. And when I do that, I get 9.9. And similarly, for this triangle, I'm doing the same thing. It's at 10.3, I think. Let me check real quick. Yeah. And when I cross multiply and divide, I get here 2.1. Ben, of course. As an aside, a useful kind of, maybe not a precise check, but like a nice little double check, is that the longest or the biggest angle should have the biggest side associated with it. The middle angle should have the middle side associated with it. And the smallest angle should have the shortest side associated with it. And they should be kind of proportional, right? Where these two are very close together, so the angle or the side length should be very close together. That's a nice little check. So the biggest angle should have the biggest side, the middle angle should have the middle side, and the smallest angle should have the smallest side. That can help if you got something kind of turned around. Usually that can catch it. Does that feel okay, Jackie? You're welcome. All right. We feel okay on the homework? Yeah, Anthony? 3? Sure. So we want to solve the triangle. Okay. First thing I observe is that this is a, oops, forgot to write that this was C. First thing I observe is this is the angle side situation, right? No, this is angle side angle. Whatever, doesn't matter. Either way, it's not the ambiguous case, right? Because I have two angles. Okay? So square right away, I know I'm going to have to find a value for angle B, for side A, and side C. Those are what I still need to find. We need to find B first. That's easy to do because it's just going to be 180 minus A minus C. So that's going to be what? 72. Okay with that, Anthony? Okay. Now if I set up the law of sines, stop talking, please. I'll have sine of B over B is equal to sine of A over A. And I guess I should fill in the value for A there. If I cross multiply and divide, I have this. And when I type that into my calculator, what do I get here? I get about 27.221. Now, you could repeat the same process for C, but I'm going to use a geometry theorem to skip having to do that. What kind of triangle am I looking at here? Because the angle measures are the same. This is an isosceles triangle. So I know that the two side lengths are the same. So I know that that one's also 27.221. But I could also have done it numerically and got it the same way as I did the previous one. Does that feel okay, Anthony?
Yeah.
Okay. All right. Let's move on then. Today, we're going to start talking about the law of cosines.
No, it's either I get every single one of them or not. I like yeah, try
So the law of cosines has three versions. So if we look at the formula for the law of cosines, what does this look kind of like?
Pythagorean theorem.
Right, it looks like the Pythagorean theorem with a little correction factor stuck on at the end, right? That correction factor at the end is to account for this not being a right triangle. If you have a right triangle, cosine of A becomes 0, because cosine of 90 degrees is 0, and that last term just drops off the end and gives you exactly the Pythagorean theorem. Is that okay with everybody? So that's pretty neat, right? So in order to use the law of cosines, what would I need to have? So I need either side angle side, where I have two sides in the included angle, or I could have side, 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 where I have all three sides. Everybody okay with that idea? Okay. The place where we have to be a little bit careful is with the side, side, side. First thing we need to do is check to see if those three side lengths are even a feasible triangle. Does anybody remember the triangle inequality from geometry? The triangle inequality? The sum of the two legs must be greater than the hypotenuse. You can't make a triangle if that's not true. Mm-hmm. Yep, it's just the longest side. So the only way it's not the longest side is if you had like a equilateral or isosceles triangle where it could be tied for first, in which case, no big deal. Still works. So good question, though. So that's easy to check, right? Just takes a moment, but you need to make sure you check it, because I'm going to promise you, you're going to find occasionally in the homework or test or whatever, I'm going to give you a side, side, side situation that's no triangle possible. I'm just going to warn you. When we solve for the angle then the angles using the law of cosines, we want to make sure that we solve for the biggest angle first. Why is that going to be helpful for us? So in the next step, where you'd probably want to use the law of sines, if we found the biggest angle first, we can avoid the possibility of an ambiguous case rolling in there, because we automatically then have the biggest side opposite the angle. So we're good. No ambiguous case can kind of roll in and screw things up and make things confusing for us. Okay? So we just, in the side, side, side situation, just solve for the biggest angle first. How do you know which one's going to be the biggest angle? It has the biggest side associated to it. So it's easy to find that. It's just one of those you just have to remember to do it, because it makes life much easier if you do that, right? Nothing weird can happen then. Everybody feel okay about those two things to worry about? Neither one of them are difficult to do. They're both really easy, but you have to remember to do them, right? Okay, so let's do some examples. Sound good? So we could start by drawing a picture, I suppose, if you want. So easy to see that that's side angle side, right? Everybody agree with that? So we're going to use the law of cosines then. Which part are we going to solve for first then with the law of cosines? Have to find side A. We don't have enough information to find either one of the other ones. So got to find A first. So using the law of cosines, A squared is equal to B squared plus C squared minus 2 times A times B times cosine of A. Now, I would encourage you guys, when you do this and do it on your calculator, to do these all in one step. I see lots of students make mistakes, especially with their order of operations, and like do this as one thing and then tack the cosine of 34 on at the end of that, and that's definitely not okay to do. So just do it in one step on your calculator. Notice when I typed this in, I took the square root of it as I was going. Since I didn't want to solve for A squared, I wanted A. Also a common mistake. Although you should have right away, or when you go back and check at the end, notice that like, not my biggest angle has by far the biggest side. That's a problem. But occasionally I'll see students do that and have all kinds of trouble because they forgot to square root to find that side length. Now that we have this answer, I can solve for either angle B or angle C. I could use the law of cosines, or I can use the law of sines. I think the law of sines is a little bit easier to deal with in this situation. That's what I'm going to choose to do here. So I can do sine of A over A equals sine of B. Actually, I'm going to do C first, over C. Hold on one quick second. Okay, yeah, it's fine. So when I cross multiply and divide, I get sine of C is equal to 17 times sine 34 over 9.506. And when I take the sine inverse of both sides, I'm just going to leave that empty. I don't feel like copying that other stuff back in there. If that's okay with everybody. Is it? Okay. You guys know what I mean, though, when I put just the blank parenthesis there. It's just the stuff from the line above. I just didn't want to write it again. So I'm pooped. You know? Ruh-roh, Raggy. What happened here? Oh, shoot. So, hold on a second here, guys. It's not a big deal, but it's a little deal. So I got an error for a reason. And it's good that this happened, right? Because now I can point this out. So what has happened here is I've kind of fallen into like an ambiguous case situation. Yeah. I didn't want to do that. So I should have done and used B. I should have used the shorter of the two sides, and then that would have been avoided. That's the issue. So it's good to see that. I want to use the shorter of the two given sides. Always. And that will avoid our issue. So I'm just going to change those things, and then I think everything will be all right. Is everybody okay with that then? It was a small mistake. I was right the first time. I was like, oh, I want to find the smaller. And then I'm like, no, I should do the bigger. Should have done the smaller. Yes. For this side angle situation, yes. You'd want to use the shorter side when we get to that law of sine step. And now to find angle C, that's very easy because it's just 180 minus 34 minus 55.4. So what is that? Like 90.6. Real close to a right triangle, isn't it? Is everybody okay on this one? Sorry I made that goof there in the beginning. But I'm glad I did, because if I would have just done it the one way, we wouldn't have seen that it definitely makes a difference which side we choose to solve with. Right? We learn from our mistakes, guys. We learn from our mistakes. Any questions on this before we move forward? Let's do another example. Okay, so let's solve the triangle with side lengths 5, 8, and 10. So clearly this is the side, side, side situation, right? First thing we should do is check to make sure that this is a triangle. So since the sum of the legs is greater than the hypotenuse, I'm good. This triangle exists. It's a real triangle. Great. So let's do the law of cosines now. So which angle should I be solving for? Yeah. So I'm going to say that 10 squared is equal to 5 squared plus 8 squared minus 2 times 5 times 8 times cosine of r. Everybody okay there? That's just me filling in the law of cosines. The way it's easy to remember for me is that the side opposite the angle is the one that's all by itself. And then the other two are just the other two. It doesn't matter the order, really. Is that okay? Just as a helpful way to remember this. Okay. What I'm going to do here is I'm going to rearrange this and get cosine r by itself. And then type the whole thing into my calculator. So I'm going to subtract the 5 squared and the 8 squared from both sides. And then I'm going to divide by 2 times 5 times 8. And that'll get cosine r by itself. This is a place where I frequently see students make like silly order of operations algebra mistakes and combine the 5 squared, the 8 squared, and then the minus 2 times 5 times 8. Do that all as one number and divide the other side by it. Big problems. Okay, and then we'll take the cosine inverse of both sides to give me r. And I'm going to do the same thing that I did before and just leave an empty parenthesis there. So I have cosine inverse of, and again, I like to use that fraction command on my calculator because it just saves me having to worry about the parentheses. It's pretty tough to screw that up because it's going to look exactly like it should on my sheet of paper. So I get 97.9. Oops. Now I can do the law of sines. And it doesn't matter now what other one I try to solve for next, because I know that I have an obtuse angle here. One triangle regardless, no worries. So let's maybe solve for P next. So if I cross multiply, divide, and then take the sine inverse, I'll do that in one step so I don't have to leave the blank set of parentheses. When I do that, I get about 29.7. And then I can solve Q just by doing P minus R. What do you guys think here? Not so bad? It's probably easier than the ambiguous case situation, right? So we'll stop here for today. Can I have you guys do for next time 15 to 22?